Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, this is video for topic 3.6, dummy variable regression model. Okay, so first of all, let's take a look into the nature of the dummy variable. Okay, again, we already learned a regression model. Okay, which the dependent variable is frequently influenced not only by ratio scale variable, but also by variable that are essentially qualitative or nominal scale. Okay, so you already know that we have independent variable and also the dependent variable. Okay, so for regression model, our dependent variable should in ratio scale, right? Okay, but for independent variable, it can be in ratio and also the categorical variable. Okay, so it can be a mixture of the ratio and also categorical variable. Okay, so for example, for the ratio, you already familiar with the condition, but for the categorical situation, okay, for example, the qualitative predictive variable, for example, is gender. So we have two categories here, male and female. And then another example is race. Either we have Malay, Chinese, and Indian. And also type of qualification. Okay, bachelor, master, and also PhD. Okay. So the qualitative variable also have their roles, okay, in constructing the regression model. Okay, so it should be included among the explanatory variable, meaning that our independent variable. Okay, so how to include the qualitative variable in regression model? Okay, so we use terms constructing artificial variables, okay, which take the value of 1 or 0. Okay, artificial maksudnya tiruan, variable tiruan. Okay, the variable that assume such 0 and 1, so we call it as dummy variable. Okay, so a qualitative variable with m categories will be represented by m minus 1 dummy variable, okay, each taking on the value of 0 and 1. Okay, for example, we have three type of race, Malay, Chinese, and Indian, meaning that our m is 3. So the dummy variable that we need to construct is m minus 1, 3 minus 1, so meaning that is equivalent to 2 dummy variable. Okay, so let's take a look into several caution, okay, several precaution that we need to ensure before we creating the dummy variable. Okay, first, if a qualitative variable has m category, introduce only m minus 1 dummy variable. Okay, as I said previously lah. Okay, let's see, we have m equals to 4. Okay, so meaning that our dummy variable should be equivalent 4 minus 1, which is 3. Okay, why? Okay, why this happen? Because if we use m dummy variable, it will result of multicollinearity or perfect collinearity, where you have a dummy variable for each category. Okay, so that's why we have to minus 1. Okay, so to avoid the multicollinearity problems. Okay, what is multicollinearity? We will learn multicollinearity for the next topics. Okay, so the category for which no dummy variable is assigned, it is known as base, benchmark, control, comparison, reference, or omitted category. Okay, but after this I will use a reference category or reference variable. Okay, but you also have to know lah. Okay, kalau kita kata benchmark tu apa maksud dia? Okay, so maksudnya kalau yang bukan dummy variable tu, okay, yang bukan dummy variable tu kita panggil dia sebagai reference variable. Okay, and then the intercept value beta naught represent the mean value of the benchmark category. So benchmark meaning that is the reference lah. Okay. Okay, next, the coefficient attached to the dummy variable are known as differential intercept coefficient. because they tell how much the value of the category differs from the benchmark category. Okay, so katakan. Okay, so let's say we have a model y hat equals to beta naught plus beta 1 x1 plus beta 2 d1 plus beta 3 d2, for example. Okay, so this is our dummy variable, okay, which is represent for the categorical variable. For x1 is for non-category lah. Maksudnya kalau variable yang ratio, contohnya umur, ketinggian, berat. Okay, so pekali untuk dummy variable ni dipanggil sebagai differential intercept coefficient. Okay, so macam mana nak interpret dia? Kita akan interpret in term of the comparison of that category with the reference category. Okay, so perkali inilah yang kita akan gunakan to make the comparison of the category with the benchmark category. Okay, and then how to determine the benchmark or the reference category? Okay, we determine the variable. Okay, basically we will use a variable that most frequent occur in the observation as our reference category. Maksudnya yang paling banyak appear lah. Contohnya antara Malay, Chinese and Indian. Okay, so for example Malay yang paling banyak kat dalam tu, so kita choose Malay as the reference category. Okay, so another precaution that we need to look into is dummy variable traps. Okay, which one we have to avoid this situation lah. Okay, so the dummy variable trap is a scenario in which the independent variable are multicollinear. Okay, so when this will happen? Okay, bila kita tak buat, okay, contoh kita ada 3 kategori, so kita perlukan 3 minus 1 equals to 2 lah, 2 dummy variable. Kalau kita tak tolak satu, then akan berlaku dummy variable trap. Okay, so to prevent this trap is by introducing as many dummy variable as the number of category of that variable. Okay, provided that we do not introduce the intercept in the model. Okay, maksudnya kalau kita tak tolak satu, maksudnya kita akan we will introduce the intercept lah. So kalau kita tolak satu, maksudnya kita boleh elakkan lah dummy variable trap ni. Okay, so how to avoid? We should produce only m minus 1 dummy variable instead of m. Okay, let's take a look into example 9. A study was carried out to investigate the relationship between the monthly expenditure, okay, and also income. Both were measured in thousand. Okay, so the gender and race of the respondent were also recorded. Okay, so meaning that we have another independent variable, which is gender and also race. Okay, and then of the respondent were also recorded. Consider only the income and gender as the predictive variable. Okay, the regression model is, okay, so let's say kita ada income and also gender lah yang kita ambil sebagai kita punya model dulu ya. Okay, so kita ada, we have yi equals to beta naught plus beta 1 xi1 plus beta 2 xi2 plus array terms. Okay, where our dependent variable is expenditure, measuring in thousand, and then we have x1 which is income, measuring also in thousand, and also our x2 is the categorical variable, which is gender. So we represent 1 as male and 0 is a female lah. Okay, or we say otherwise. Okay, so to interpret beta 1, we already know, or we already learn before this. Now we want to focus on the beta for the categorical variable. Okay, so beta 2 indicate how much, okay, higher or lower the mean response is for male to female, okay, for any given level of income. Okay, kalau higher tu maksudnya sign dia positif lah, kalau lower tu negatif. Okay, maksudnya kita nak compare antara lelaki dan perempuan lah. So we just only have male and female. So kita nak compare between male and female, berapa dia punya beza dia. Okay, berapa lebihnya lelaki punya income, berapa kurang terhadap perempuan lah. Okay, so let's say the following estimated regression function is given. Y hat equals to 0.5 plus 0.15 x1 and plus 0.75 x2. Okay, so we focus on this value lah, because this is for the categorical variable. Okay, so beta 2 is equivalent to 0.75. Okay, so this indicates that with income held constant, the average expenditure for male respondent is found to be 750 higher than female respondent. Okay, so since our female is our reference category, kan? Okay, so maksudnya male is 750 higher than female respondent. Ingat, kita mesti compare kategori tu dengan dia punya dia punya reference category. Okay, so let's see. Okay, katakan kita ada value x1 tu adalah 3000. So kita masukkan ke dalam equation ni. Okay, so macam mana kita nak masukkan? Okay, first katakan kita cari dulu y hat untuk male. Okay, so male tadi kita dah tahu dah, kita gunakan notation 1 ataupun 1 represent male lah. So kita ganti dekat dalam x2 ni dengan 1. Okay, so 0.5 plus 0.15 times 3000 plus 0.75 times 1. So kita dapat 1.7. Whereas for female, okay, kita gantikan dekat x2 ni kosong. Sebab 1 tadi represent 1 is for male, 0 is for female, right? So kita nak dapatkan dia punya estimated value for the function. Kita gantikan ke dalam x2 tu dengan kosong. So kita dapatlah y hat untuk female is 0.95. Okay, so kita boleh cari dia punya the difference in average expenditure for male and female. Okay, yang mana kita tolak kan 1.7 minus 0.95. Okay, so surprisingly we get 0.75, which is equivalent to value of the beta 2. Okay, so maksudnya that's why dia punya interpretation for the beta 2 macam ni. Kita nak dapatkan how much the difference between male and female. Value-nya adalah value beta 2, ataupun sebenarnya macam ni lah cara dia dapat value 0.75. So value ni kena samalah, masukkan kedua-dua equation value yang sama. Kalau awak nak try 1000 pun boleh. So nanti differ dia, you will get the same value, which is 0.75. Okay, now let's take a look into example 10. Let us consider including race. Okay, so we have Malay, Chinese and Indian as a predictor variable for the study on the expenditure. Okay, tadi kita dah ada gender, now we include pula race. Okay, so meaning that we need to create 2 dummy variable. Okay, since we have 3 category here, Malay, Chinese and Indian. So M equals to 3. Okay, so the dummy that should be developed is 3 minus 1 equals to 2 lah. Okay. So the regression model is given as follows. Yi equals to beta naught plus beta 1 xi1 plus beta 2 xi2 plus beta 3 xi3 plus beta 4 xi4 plus error terms, where y is expenditure, x1 is income, x2 is gender. Okay, for categorical, and then dummy yang pertama lah. Okay, dummy yang pertama is untuk gender. Okay, so kita ada 1 is male, 0 is otherwise. Okay, and then okay, sometimes we use notation D. Okay, so we have so this one is D1, D2, D3. Boleh juga nak guna simbol D pun boleh. Okay, so untuk this one adalah untuk gender punya kategori. Okay, yang ni untuk dummy yang untuk race, okay, where 1 is Malay, 0 is otherwise. Okay, untuk X4 is dummy for Indian, 1 for Indian, 0 for otherwise. Okay, so if you recognize here, our reference category is, so kita punya reference category kita adalah Chinese. So nanti kita nak buat comparison antara Malay. So kita akan buat comparison nanti untuk interpretation dia antara Malay and Chinese, Indian and Chinese. Okay. Okay, so kalau tak nampak, kita tengok kat bawah ni. So the three category for race are represented by the dummy variable X3 and X4. Okay, so X3 is represent for Malay, X4 is represent for Indian. So Chinese tu kita akan represented by the 0, 0. So any category that represented by 0 is, we call it as reference category. Okay, so let's say we have, katakan kita ada satu lagi kategori untuk race ni. Kita ada Malay, Chinese, Indian, and also katakan ada others. So maksudnya kita ada 4. So kita kena construct 4 minus 1, 3 dummy variable lah. So kita kena tambah satu lagi dummy, we call it as X5. Okay, katakan kita punya Chinese still our reference category. So kita akan assign value, okay, sini others. So dia akan jadi 0, 0, 1 kat sini. Okay, so dummy yang kelima nanti tambah kat sini lah. X5 equals to 1 for others, 0 for 1 for untuk others kategori lah. Okay, others kategori, 0 is otherwise. Okay, so maksudnya kalau untuk X5, kalau value 1 is represent the others race in Malaysia. Okay, so let's say we have back to our example. So let's say we have the estimated regression function is y hat equals to 0.1 plus 0.2 x1 plus 1.5 x2 minus 0.3 x3 plus 0.884. Okay, now kita nak interpret beta 3 and beta 4. Okay, meaning that for the new categorical variable that has been included here, which is race. Okay, kita tengok beta 3. So beta 3 is equals negative 0.3. So this indicate that the average expenditure for Malay respondent is found to be 300 lower than Chinese respondent. Okay, why lower? Because the sign is negative. Okay, so Chinese ni adalah kita punya reference category lah, and then kena tambah holding income and gender constant. So variable yang lain semua kita hold constant. Okay, for beta 4 we have 0.8. Okay, so this indicates that average expenditure for Indian respondent is found to be RM800 higher than Chinese respondent, holding income and gender constant. Okay, so kat sini kenapa dia higher? Sebab simbol dia positif. Okay, so maksudnya it indicates that Y kita, okay, so this is our Y. Okay, for Indian respondent is found to be 800 higher than Chinese respondent. Okay, so kita tahulah sebab X4 ni kalau value dia 1, dia adalah untuk Indian kan. Okay, so that's why kita compare dengan Chinese lah. Kalau ni tadi dia adalah untuk Malay, so Malay kita akan compare dengan Chinese juga sebab Chinese is our reference category. Okay, so ingat ya, simbol ni memainkan peranan lah, menunjukkan either it was higher or lower, okay, for that category. Okay, so another model is models that we already learned. Okay, so we have a model the dependent variable with respect to several independent variable. Okay, but you have to bear in your mind our independent variable is not only by ratio variable, okay, but also qualitative variable. Okay, for example, gender, race, educational level, and so on. Okay, so to deal with qualitative, again, we introduce the dummy variable. Okay, so selain daripada ANOVA, analysis of variance, okay, now let's introduce into UNCOVA model. So meaning that, okay, kalau ANOVA, our independent variable, semuanya dia punya scale dia adalah ratio. But for UNCOVA, okay, our independent variable, which is our x lah, it was mixture between ratio and also plus categorical. So that's why dia dipanggil UNCOVA model. Okay. So, regression model containing a mixture of quantitative and qualitative variables are called analysis of covariance or UNCOVA model. Okay, so please remember, if we have qualitative and quantitative variable for their independent variable, the model is called UNCOVA. Okay, so how to test on the significance on individual regression coefficient? Okay, so for the dummy variable or dummy regression, we are interested to compare the difference in the mean value of two or more groups or category. So our hypothesis is still the same, beta, whether it's equals to 0 or not equals to 0. Okay, so we still use the t-test or we use the p-value. Okay, so the steps are still the same when we conduct analysis of variance. Okay, cuma bezanya kat sini kita nak compare the mean value between the groups. Okay. Okay, look at example 11. In a study of average salaries among public schools teacher, the economy wishes to relate the average salary of public school teacher in several states and district for the academic year 2020 to 2021. This area are classified into 3 geographical regions. So we have North, South, and West. Okay, suppose we want to find out the average annual salary of public school teachers differs among the 3 geographical regions of the country. So we have North, South, and West. Okay, so the data is actually looks like this. Okay, so we have salary, spending, and then we have dummy variable D2 and D3, where D2 is equals to 1 for state in the north, okay, 0 is otherwise, and then for D3 is state in the south. So meaning that our reference category here is west region. Okay, so kalau kita totalkan, okay, contoh untuk kategori 1 is north, totalkan, then we get the on average the average salary is equivalent to 49,538.71. And then for south, okay, so we add up the D3, okay, D3, the salary we will get 46,293.59. And then for the west, okay, other than so meaning that we refer to the D2 is 0, D3 0. So we total up the salary, we will get 48,014.62. Okay. So this number looks different, but are they statistically different from one another? So that's why we developed the regression model. So the regression of this data on this dummy variable yields the following model: yi equals to beta naught plus beta 1 di1 plus beta 2 di2 plus mu I. Okay, so the first dummy variable is represent for a state in the north, okay, and 0 otherwise. And then for the second dummy variable is the state is in the south. Okay, so meaning that our reference category here is region in west. Okay, so based on this model, what we get? Okay, the mean salary of public school teacher in the West, okay, which are our reference category, is given by the value of beta naught. Okay, so untuk reference category, dia punya average salary dia ataupun mean salary dia adalah value beta naught tu lah. Okay, nanti bila kita ada the estimated function, so the beta naught is referring to the value for the reference category. Okay, whereas the coefficient for the first and second dummy variable indicate by how much the mean salary of teacher in the north and south differ from the mean salary of teacher in the west region, which is our reference category lah. Okay, so untuk the first dummy variable ni, kita nak compare mean salary antara south region dengan west. Okay, sebab west kita punya reference. Okay, so this one is our reference category. Okay, untuk dummy yang kedua, kita nak compare antara south dengan west. Okay, yang first tadi north dengan west. Second dummy variable is between south and west region. Okay. Okay, after we analyzing the data, we obtain the following estimated regression function. Y hat equals to 48,014.615 plus 1524.099 D1 minus 1721.027 D2. Okay, and then you are given the value of standard error for each coefficient, the t value and also the p value. Okay, so now we want to interpret the regression result. Okay, so we write back what is our model here. So we have y hat equals to beta naught plus beta 1 x1 plus beta 2 x2, or we also can write this as d1 or d2, represent the dummy variable. Okay, so now first we want to interpret the value of the beta naught. So beta naught here is referring to this value 48,000 and 40 ringgit 0.615. So meaning that we can interpret here the mean salary of teachers in the west is about 48,015 ringgit. Okay, so this one is the value for the beta naught, our reference category, which is west region. Okay, and then value for beta 1, okay, which are the coefficient for the first dummy variable, is equivalent to 1,524.099 ringgit. So meaning that the mean salary of teachers in the north is higher by about 1,524 from the mean salary of the teacher in the west. Okay, so remember that our first dummy variable is referring to the north region, and we compare with our reference category, which are west region. So since the sign is positive, so that's why we say that teachers in the north has the higher salary by about 1,524 compared to the west, which is our reference category. Okay, so the mean salary of teachers in the north region is about 49,539. Okay, so how we get this value? Okay, so we substitute into the model that we have. Okay, so kita ada yi equals to 48,014.615 plus 1524.099 kita darabkan dengan 1. Okay, why 1? Because the dummy variable yang pertama, the first dummy variable is represent the teacher in north. Okay, so kalau teacher tu berada di north region, so kita substitute with 1, so we will get 49,539. Okay, so and then the second coefficient for the second dummy variable is equivalent to negative 1721.027. So meaning that the mean salary of teachers in the south is lower by about 1721 from the mean salary of the teachers in the west. Okay, why lower? Because the sign is negative. So again, remember we are comparing, okay, the second dummy variable is between south and the west, okay, which is our reference category. So how to get the value of the mean salary of teachers in the south? Okay, we take the estimated function. Okay, so we have y hat equals to 48014.615, okay, minus 1721.027 times 1. Okay, kita tak ambil value yang tengah-tengah ni sebab yang tengah-tengah ni adalah untuk north. Sekarang ni kita nak kira the mean salary untuk south region. Okay, so we are focusing on the second dummy variable, and then kita gantikan value D2 the second dummy tu with 1 because 1 is for the south region. So we will get the mean salary of teachers in the south is about 46,294. Okay, bila kita gantikan dekat second dummy variable with value 1. Okay, so kita anggap yang first ni tak ada lah sebab sekarang ni kita fokus untuk dummy yang kedua. Maksudnya kita nak compare, kita nak dapatkan mean salary untuk teacher in the south region. Okay, so maksudnya kita akan tambahkan value beta naught plus beta 2. Yang mana yang D2 tu ataupun X2 tu kita kena gantikan dengan value 1. Okay, so then what can we interpret based on the output? Kita boleh interpret ataupun we can identify which variable that are significant atau which dummy variable that are significant. So we can see from the regression, the estimated slope coefficient for the north is not statistically significant. Why? Okay, look at the p-value. P-value is 0.522. Okay, and also for the south, the p-value is 0.4888, which is more than our alpha, which is 0.05. So we will reject hash naught if our p-value less than or equal alpha. But for this case, both p-value are more than alpha. So we can see that the mean salary of public school teachers in the west, north and south are about the same. Maksudnya no difference. Their mean in terms of the mean salary of the public school teachers, because we are failed to reject. So meaning that there are, so kita punya beta naught and beta 1 hash naught and h1 is beta j equals to 0, beta j not equals to 0. Okay, for the h1 kita nak we say that there is difference. There is difference in the mean between the category lah. There is difference in the mean of the category. For this case, the mean of the salary. Okay, so since we are failed to reject, so we conclude that beta j are equals to 0, meaning that there is no difference or the mean salary are equal.